we wanted to, at least from the local, from here locally, we wanted to run this little bit interactively. So I'm going to run this session as though we are interactive, although I understand that you cannot, you can't interact with me. And if any of you has got any any environment with you, a laptop or anything, a development environment ready, it would be a good thing to just take a look at the stuff that we are doing and maybe try a couple of things out. Okay, I will show you the screenshots of the specific environment that we are developing through, and we'll run through from there. Okay, so we begin with the agenda for this discussion is essentially to understand how to automate your unit tests. There are several ways of being able to automate your unit tests. You can use there are as many number of tools as there are languages. In fact, for each language there must be at least 3 to 4 different types of tools that are available for the market. So the amount of tooling that is available for automating your testing is just incredible, and it is very difficult to be able to actually choose and select what you want to go with. But one of the more important things is that a framework like JUnit, which is a mature framework, has been around for many years, and it's also a fairly simple framework. It's something that is very easy for anyone to ramp up with, and that is definitely a very good starting point for people beginning to work on test automation. And this test automation is of a slightly different nature. So what we are going to try to understand today is, just give me a moment. Hey Ravish, so I had shared that. Can you see the scroll? Can you see that screen now again? No.
No, Rajiv. Can you share it again?
I think after you turn it live, it probably stopped the sharing. Okay, now it's fine.
Yes, Rajiv.
Okay. Yeah. So the important thing that we are going to cover in sequence today is number one is, first of all, why is it the developers or the responsibility of the person who is writing code to do any kind of unit testing? We all understand unit testing, but we really don't take it as seriously as it needs to be, and the whole situation turns around that we rely on QA to trap our test. So the first part of our discussion is about how unit testing actually is meaningful for developers, and that's one message that you absolutely have to understand, because without which it is almost impossible to actually proceed with some of the concepts and some of the important learnings from how JUnit is used and what is the meaning of test-driven development, etc. If we don't understand the motivation, it is extremely difficult for us to be able to even understand what the specific designs and what are the specific concepts that JUnit tries to elaborate. I am assuming that all of you as developers or managers or team leads have at least had some basic exposure to JUnit, heard about it, read about it, seen somebody in your team do it, seen somebody in another team do it. But that's where, so we'll start there. We'll go to understand what JUnit is all about. We'll understand from JUnit how the tests are actually constructed, how simply the tests are actually executed, and then understand how we use the things called as automation concept called as mocks or doubles for making testing easier for the developer. And then finally we end the session with a few code samples from the actual code base that we have. Later we'll move on to a simple Q&A session on whatever concept that you probably missed. Okay. So we know that programming always starts with requirements. We all understand the fact that you have been given certain requirements, certain business requirements, certain functional requirements, there is a very clearly spelled out objective that any program has. We all know that the outcome of a program is obviously very specific and unambiguous. We are not in a world where we have to use artificial intelligence, machine learning, etc. to be able to devise an automatic intelligent solution to the problem that has been given to us. In all the standard business scenarios and cases, the problem domain and the solution domain are finite, are limited, are specific, and very unambiguous. Right? This makes it very straightforward to be able to say that I want to achieve this goal, and therefore I'm going to start writing my code like this. So you essentially sit down, you have a design session, you think through what is required, you see what tools you're going to use to implement the solution, you start writing your code, and then you're into the flow, as we call it. In the classical scenario, the programmer validates the output via 3 modes. Okay, how do we actually start writing code? And this is something that we've all done as developers, junior developers, when we have started, when we started writing, when we have written code on projects and stuff like that. Everywhere we write code, this is what we do. We understand the requirements, and then we put the design on paper. Potentially, we put the design maybe in a more formal document which explains what the design has to be. But the moment we start coding, what we do is we verify the output of our program in 3 different specific ways. One is we look at the console to see whether or not what we are generating is correct, whether that particular program is doing what it's supposed to do. We read the messages that come out on the console, exception messages, compiler messages, other kinds of messages. And then when those messages are limiting, what we do is we add additional logging statements or logging artifacts in the code to capture what is the context in which a particular thing happened or didn't happen. So logging is a very standard way of debugging, of writing your code and running it through and be able to see on the screen that yes, step 1 happened, step A happened, condition 3 passed, and this condition was not valid, and my program was able to trap it, so on and so forth. So you say if this condition passes, log this, right? And we have different levels, different log levels, like log.info, log.mon, log.debug. If any of you have used the logging framework, then typically we have different levels of logging. Based on those levels of logging, we add logging statements to our code and then track them depending upon how badly our program is doing. If it is doing fairly well, we are just interested in the info statements. Otherwise, we might want to look at some warnings just to understand that the program is behaving the way it's supposed to. We might look at errors. Finally, we might look at the whole debug so that we are able to track down the problem. Finally, the most standard way of working through verifying a program is to debug the program and validate its variable. So you actually start off the debugger, you launch the thread, it stops, it pauses, you look at the stack, you look at the variable information, you compare it with what you expected. Obviously, the reason is here because you cannot write infinite log statements all over your code. It is not only humanly impossible, it is also difficult to control, and it's also difficult to read in the end. So you drop out of logging, and then you start debugging your program in the attempt to understand that it is doing what it is supposed to do. In other words, you have at least 3 different ways of being able to verify or being able to ascertain that that the program is doing what it is supposed to do. This is the environment that all developers work in. Now, just imagine a scenario where a programmer is collaborating with his team, and then on a daily basis they have a process where they are supposed to exchange Excel file listings with the potential check-ins. It's a very hacked out scenario. Obviously, it doesn't happen in most cases, but I've seen this happen as well. Is that team members send advance notification of the fact that I am going to be doing this, so you can pre-verify what is going to go into the code base, right? And sometimes these are also used for code reviews, etc. So let us say that the Excel file listing is has a list of the check-ins along with the locations of where the files are to be found. Now, what a guy has to do, a team lead or another team member, he needs to copy them over locally and then maybe do a diff, maybe compare, do whatever he has to do. Right? This is the whole thing. This is the whole scenario. So this is a daily process, and obviously you don't like it. As a developer, you resist the fact that, oh my god, I have to go start looking at these files, put them in one place, and then compare all of those all the different situations and put them back. Guess what happens? Before you know it, I know that in many scenarios, as soon as this kind of a problem is given, in less than a week, before the problem even starts, a developer has a Python script ready to tackle the daily headache. Right? He absolutely knows, he just doesn't want to frustrate himself with having to go through each item in each item on the list in the Excel file, and then find where those files are, pull them down, and then do a diff. He's not going to do that. Right? Developers are very smart at being able to find solutions for problems that are affecting them. Now, the moment this guy has written that script, before the team can even use it, you can be pretty sure that another guy has a bright idea, saying, you know what, we can plug this directly into Eclipse, and then as soon as we are writing code for a specific file, we will be able to auto detect the Excel, auto detect the files that are given in the Excel, and you know what, I will be able to see the update right there in my Eclipse environment. So what the developer would want to do for him, and to obviously as something that he wants to be able to prove to his team, is essentially that, you know, obviously he's a script group, and he's obviously not going to have you know, this stuff come in the way of his profuse coding. The kind of code he turns out day on day, nothing can come between that and obviously what he's designing, and that's something that he wants to. That's something that we all take great pride in. Unfortunately, it's the same developer who has absolutely no problems permanently destroying his carpal tunnel by tapping F8, F7, F6, stepping through the debugger to check if his program works correctly. Now we've seen that happen all the time. To be able to really thoroughly understand a program, we step through it several times over. We cycle through it in one direction, we cycle through another flow, we pass another parameter to the web page, then we break it at another different point, just to be able to introspect and understand what are the paths that the code takes. In other words, as programmers, actually, true programmers, we love to automate everything. The one thing we hate to automate is test. Okay. Program verification is nothing but testing, and this is something that we need to internalize and understand, that whenever we are actually trying to understand what a program does, whether you're setting through debugging, writing logs, viewing the console output, you're actually verifying the program. That, in a sense, is exactly what testing is, and automating that program verification is nothing but JUnit. Just give me a moment. I think there's a small distortion. 1 second. Okay, and automating program verification is nothing but JUnit. That's as simple a message as I can hopefully give to everyone who is attending the call, is that all you're doing by writing JUnit is essentially verifying that your program works correctly. And JUnit is a powerful tool which assists you in developing the verification and making sure that your code is working correctly. Number one, when you write unit tests, they serve as communication. They help you understand the fact that this is what I intended to write, that the function was supposed to do a sort in the ascending order for this to work. So the moment you actually write down a test which says test for ascending order, you have already communicated your intent. and that intent then becomes visible to other people who are going to look at your code again, or who are going to try to understand your code again. When you have something that actually verifies your intent, there is no bigger or powerful message. No documentation, no inline documentation, no amount of external documentation. There is nothing that can be more powerful than a simple test code which says this is what this piece of code does, and this is how it does it. Right? That is number one. This is what it allows you to do. Number two, when our program stops working, typically we tend to go in a complete haywire manner, in being able to grasp. The bigger it is, the more dependencies it has, the more third-party institutions it has, the more tools that we are using. Our program is just a small part of that ecosystem typically. We never write tests in isolation. Yes, that used to be the case when you started off, when you had to write one program at a time doing one specific thing. But in a typical scenario, your test is in the middle of a huge ecosystem doing a whole lot of things and talking to a whole lot of other libraries and processes. So it is extremely difficult for you to be able to ascertain without the whole the whole environment up and running that your program does what it's supposed to do. So tests help reduce the anxiety that your code produces. The bigger the code gets, the more lines of code you write, the more you have to worry about the fact that each one of them actually does what it is supposed to do, and all of it is actually all inside your head. It has never been validated. It has never been certified. You don't know whether it really works or not. You essentially have a gut feel that you're good enough that this works. And I'll tell you the honest truth that even the most veterans of the industry today, and you would look at the people, if you go look up on the web and you see the developers and design, especially the design professionals in different Ruby, Java programming environments, there is one message that they always give you, regardless of how mature and how many years of programming you have put in. It works the same way for everybody. It's not that as you grow into 4 or 5 years or 6 years, you tend to drop the fact that I have to do all this verification. No, I'm good enough. That never happens, because programs by their very nature are complex and they depend on a whole lot of different things to get together for you to be able to make sense of them, and it is impossible to keep this sense in your head. When you have a battery of automated tests, you have essentially verified and proven to yourself that all the code that you've written so far continues to work the way it is supposed to. The moment you write something that is odd or something that is out of place, the first test that fails immediately tells you the location that you're supposed to go fix. You don't have to go find it, you don't have to go debug it, you don't have to go look at the logs, you don't have to do anything. All you have to see is the test that failed because of a new parameter or a new condition that you introduced into your code, and bang, there it is. Right? That's exactly the place where you go find the source of your error, fix that, and you're back in action. So they basically give you the confidence to be able to develop further on what you're doing. Obviously, as a continuation of the previous thought, it also confirms that the underlying code is in good shape. Everything that you have built is essentially is steady, is stable, is robust, and then whatever you write on top of it becomes something that you can rely on. The most important part and the most valuable part of this whole thing is, once you have written that code, essentially every day that you write that code and you write tests along with it, you can absolutely and conveniently and safely forget the implementation details. So that's the one thing that I've seen most programmers run into head on, is essentially that the whole design picture is either on a notebook or a notepad or in their head, and every day until those 6-7 days or 3 weeks of crunch time, they're holding all these elements in their head, and they're having various permutations and combinations. They come and try out different ideas, but the entire actual the content of the real design is all in their head or on paper, and there is no way they can actually forget everything that they have done in the past 2 weeks. They need to understand why did they introduce this particular class or this particular variable, or why was it sorted like this. All of this is very clear. They have to maintain that information, that reference information, until that thing is done and delivered. Now just imagine that after 3 weeks of delivery, when somebody else picks that piece up, how much of your actual assumptions and actual things and design principles that you implemented, you have to communicate to the other guy for him to be able to make sense of the code that you did. So essentially, when you write tests and when you write individual at each level of the unit, at each level of your program, it allows you to be able to say, you know what, I've thought through this problem, I've worked through this problem, it's done, it's proven. And you move on to the next thing. And if you want guidance to understand what happened before, all you have to do is go read through the test, and that's your anchor for being able to move faster and further. Kent Beck's quote, not mine, and as he has said, perfect is a verb, not a noun, and that's one of the things that that one of the most important qualifiers of what is the assumption when you start writing code, is the fact that you are going to incrementally and slowly and gradually improve upon that code. You are going to work through it slowly. You're going to understand what its limitations are. You're going to have tests that verify. You're going to write new tests that confirm new conditions. You're going to capture those conditions. You are going to refactor those tests. There is a cyclical. There is no such thing as, actually, if you look at it, we hear the word done in a lot of places as is the program done, is the work done. Essentially, being a language and being a nature of communication, programs are never really done, because there is always a certain amount of scope, always a certain amount of functionality, or always a certain amount of boundaries that you left out of the scope of the program that you never intended originally to design for. As the program starts getting used and in real world situations, you come across different scenarios and you tend to improve upon its quality, and you tend to go through these cycles multiple times to essentially become closer and closer and closer to perfect. Once again, you should never make the statement saying it's done or it's perfect. It cannot be. I was just reading an anecdote the other day about the fact that the most simple binary sort algorithm is something that people have only recently been able to write sort of perfectly. Because even something that is as old as about 10 or 20 years in the domain had a bug which was identified as recently as last year. So when you find a bug, it is not an indication of the fact that that you thought badly. It is an indication of the fact that you didn't think through that, and now you must go take care of it. And therefore, the moment you have extensive battery of tests, it then allows you to move through the cycle faster, so that you are moving towards perfect. Now we come to the core of this discussion. Essentially, since you are now able to understand the gravity, or the fairly, I have no better word to use for it, but the amount of leverage that you can get out of harnessing or constraining your code with tests is significantly huge, and it becomes when you actually start writing it, it becomes a philosophical shift in your mind. It becomes something that you really like to do. And if you go look at the JUnit website, you will find one article called test infected, and that is the real term. When you actually start using it, you essentially get infected, because then it becomes addictive. Because that's something that becomes something like something that you rely. That's something, you know, it's your comfort zone, and you feel good when you go out every evening. That, you know what, everything is where it should be. So to achieve this kind of a shift, you would assume that, you know, obviously I have to write a whole lot of things, and typically the standard automation and the test tools that we have in the market, the kind that are used for production environments, the kind that are used for load testing, web testing, etc., are essentially fairly heavyweight, because their objective and their focus is completely different. And that is another thing that I would like to stress, many times over during this session, is that there is a big difference between what the QA team does versus what the developer does, and this is always a big source of confusion to developers as to what am I really doing. To truly understand unit testing, you essentially need to understand that you are writing the code, writing the test to make sure that your algorithm or your design or your rationale or your logic essentially suits the purpose of what you are working on. It does not necessarily have to work through all the different integration scenarios, whether or not the specific vendor invoice was sent, whether the invoice was received. All these are functional issues which fall into a different domain. What you have to figure out is whether your representation of an invoice and the methods and messages that you have on that invoice actually work and do what they're supposed to do. For example, you know, converting different amounts of money, adding interest rates. Those specific things are the focus of the unit test. So the complexity of being able to test and being able to write unit tests is something that obviously developers find very difficult to imagine, because what they want to be able to do all day is code, is write programs, right? But again, thankfully, JUnit tests are dead simple to write or run. In fact, they're even simpler to learn. So in a typical JUnit test, a JUnit test is nothing but a very simple Java class, a simple Java program. And to be able to identify the fact that you're writing a test, all you have to do is prefix the test with a method, prefix the test method with a simple keyword called test. The JUnit API, reflection, and there is some design pattern, command pattern, which all then puts this whole thing together, and then it identifies those tests, compiles a list of the tests, and runs them through, and that's it. This is as simple as that. All you have to do is write a simple class. Now, if you did not want, for example, that class to be testing when you start with, because you're not sure what your test does, you can essentially take out the prefix, and then that will not be a part of your test collection. So writing a test essentially is simply writing a method with the prefix test. This is our first look at the simplest test case that you can possibly imagine. You have an import for the JUnit test case class, and then, you know, whatever you want to call your test case that you're writing, and then the method called test string index, like I said, prefixed with the keyword test. Once again, I would like to underline the fact that we are discussing this in the context of the JUnit 3x versions. In the JUnit 4 version, things have improved even more dramatically, and a whole lot of this scaffolding has been taken away, and all you have to do is essentially use a whole lot of smart annotations to mark your methods as, you know, whether they are testable and whether they are a suite, and all kinds of different things. So the JUnit 4 framework is slightly different, but you know, given the developer environments, given the legacy of the test cases, etc., 3x series continues to be in a fairly large use in most of the production environment. So now The important thing to notice in this program is that there is a test method, but the actual test inside that method is the assert method, which is assert equals hello world dot index of space should be 5. Right? We expect that this test should pass, because if you count the characters in the string from hello, you essentially get to the 5th based on zero base index. So essentially the 5th position of the spaces, you expect it to pass. So we say assert equals. Now what we are doing here is we are testing whether the index of method of the string class works the way it is expected to work, right? And there can be several different types of tests that you can execute on this, and we'll see that in a moment. So when I run this test, what happens? I have run this test in Eclipse, and there are obviously many ways of running JUnit tests. There are a lot of sophisticated tools built on top of JUnit which allow you to run them in a different manner. But 2 or 3 of the simplest ways of running JUnit tests. One is from your Eclipse or NetBeans development environment. You directly execute your call test case and execute the test. The other one is via the command line, and the third is via ants, and that is the most standard use of JUnit because they generally have to be automated, and they have to run along with the whole bulk of code that you have written so far, and therefore in a build cycle it typically gets automated with the ant build tools, and you see the output of the entire test on your whole package, instead of just limiting yourself to the one that you're working on. But if you're developing a unit, essentially while you're in the integrated environment like Eclipse or NetBeans, you are able to execute tests right there and see whether they will pass or not. This is just an example of the output failures in case a test does not work. So what I did was simply replace the fact that hello world dot index of space, instead of 5, I changed that to 1, and therefore in the next situation the test fails. This is as simple as a JUnit test can get. Okay, I'm not sure this is a good time to for anyone to ask context specific questions, and if you want to, please do that. But if you want to hold off to the end as well, that's okay with me. I'll let you message to Ravish or in the chat window, so we can stop and take a question if that's required. Okay. Moving on from a simple test scenario. Now, obviously, we are not going to be writing tests as simple as that, and there are many different complicated situations that arise when you're writing tests, and obviously not all of that is in the scope of our discussion today, but we will try to cover the ground which at least gets us to understand how various elements of JUnit get together to get the job done for us. One of the important key concepts in a test environment or unit testing or any kind of testing, in fact, is that you typically start with some kind of a context that a particular, for example, a particular service is available, or a transaction has happened, or rather there is a bank deposit, right? A user has an account in a bank. What happens is that something is a particular operation happens on that in that context on some entity within that domain, within that functional domain. So, for example, in the case of a bank account deposit, a transaction is made or a withdrawal is made. When a withdrawal is made, you expect that the overall balance in the account should be reduced by the amount that has been withdrawn. This is always the standard harness for any test. That's why it's easy to remember that it is always composed of given, when, then, kind of a structure, regardless of whether you're writing JUnit or so. This terminology actually comes from tools such as behavior-driven development tools, which are one example of that is JBehave, and it's a very powerful tool. And I would have liked to spend some time on it, but I don't think we will have a lot of time to discuss that. Nevertheless, I do encourage you to look it up, because it's a different way of being able to express your test. So although JUnit does allow you a lot of simplicity in writing your tests and building them, JBehave goes a step further in being able to bring it closer to the functional domain that you're working with. That's enough about JBehave. However, it is important to establish the fact that we are working within a context-driven structure. So a test has a context under which it operates. This is a given set of conditions. In most references, these are also called as fixtures, or the objects. You can imagine fixtures to be since we are discussing JUnit, you can imagine fixtures to be essentially the Java objects or classes that you are interested in, and that have been initialized and are ready for a particular scenario, and then an operation is performed on another unit, leading us to a test condition. So under those conditions, under that global context, when a new operation is performed on the program or the unit, and by unit we mean the actual operation that is under test, then we can make certain assumptions about the output of the operation, right? That as simple as that. That the expected outcomes are verifiable. We can test them. We can make sure that whether it's a list that has been outputted, or a string, or it's a number, it essentially has to have some expected value because your program acted on it and changed it in a certain manner. So this basically, once again to repeat it, there is a context under which it operates, which is the initial set of conditions. These are also called as fixtures. Under those initial set of conditions, a new operation is performed on that unit. That new operation causes certain values to change, and you are essentially making assertions on the outcomes of that operation. Okay. In JUnit, we refer to the global context or the global condition or the test condition that we are working against via a special method called setup. Okay, and this is the example of a setup method. Obviously, all these examples are not complicated, and they're intentionally left to simple. But the idea is to be able to convey the point of how it is done, rather than actually go into the different, because that's obviously a different session, and that needs to be a little bit more hands-on and driven by the context that you are working. So a simple method called setup will tell you that, unlike the previous case where we went directly into the test, if you remember, okay, where we had a direct value that we were testing against, what we are doing now is we are saying that I do not know what my two values are going to be, but I will set them up initially and get them to run. Now, so there are two test cases now. Test concat, which is method equals verify that strings can be added with the plus operator. So what we are saying is, this is a slightly different usage of what we have done so far. Try and understand this. In this particular case, we have added an additional message which says what is it that I am testing for. Okay, this is not the most idealized of tests, and there are some issues I can see here in the positioning of the value, etc. But anyway, the first argument is essentially actually now you have introduced something called as a message, a meaningful message that you can understand in case the test fails as to what went wrong, as something that you can interpret. Otherwise, all you get is a test failure, right? So you have a concatenation test. You say that this one works. Now, as you can see, the next test still verifies that the index that we get the index value properly. The setup method in JUnit establishes the global context. Each test now has access to that same context that you set up initially, those two variables that we are talking about. Now my question, I mean, it was supposed to be interactive environment, but the question is, will test string index pass? Okay, let's go back and look. Oh, sorry, actually, one second. So let's look at the program again. Is this expected to pass? Remember that I have set the value of second to where? In test concat. When I finish test concat, I set the value of second to where? This does not work, essentially because the setup works on every specific test case at a time. Okay. It is not a general value that you can play around with during the test. You set up the initial test condition, then that test condition is supposed to be valid for the different test scenarios that are executed. I mean, I've already mentioned that, but you can pass the message argument to assert methods. So we have gone through basic scaffolding. We understand that there is something called as a setup method, which allows us to initialize certain conditions for different tests to operate under. Now our life becomes more complicated, obviously, because we are not writing 2, 3, or even 5 tests. In any given scenario, as you can imagine, if you write the simplest program, whether it is sort something or whether it is a string search, the simplest program has innumerable permutations that you have to test against, and you can take that as a mental exercise. And for example, see what are the different test cases you would write to ensure that your program, for example, searches for a given text in a file. And if you were to think over all the different permutations and scenarios that were possible around it, whether the file is there or not, whether there was some problem reading that file, whether or not, what kind of content that file has, what is the kind of how much is the volume of data, for example, in that file that your program can load. So there are many different permutations you come up with. So you essentially, for a typical unit, you would expect a minimum of 5 to 10 test cases for a very small lowest level unit, right? I mean, I'm not talking at the method level. However, at the class level, you might expect this to obviously multiply 10 or 20 fold into about 100, or for a class which does something reasonably meaningful, you would expect that your test cases are at least in the range of 100, and that's not a joke. I mean, that scenario should happen. If it's not happening, you're obviously missing out on certain things that you should be doing. So you should be very worried if, for example, your entire class is being tested by only 5 or 10 methods, and it's generally not appropriate. One thing to remember is that for each particular test case, there are multiple assert statements that can be within the same test call. You don't have to have each assert statements in a separate method call, right? So given a test method, you can write many assert statements, but remember that those assert statements are applying to the unit under test. The unit under test or the system under test is an important keyword. So the unit under test is being verified, and therefore the assert statements are applicable to the unit that you are looking at, and therefore they are limited. To be able to cover the span of what is happening across your class, you need to be able to write different test cases which have different types of assertions with different types of outcomes which get tested against. This is where comes into play for JUnit. So again, we have the same class, the public class whatever, which extends the test case, and as you can see, you're familiar with all this, right? Okay. So as you can see, we have the same. So we have the setup method as is. We have the test concat method wherever it is. So what we are doing instead is, if you can see the last method here, there is an additional method called the suite method, which defines a specific test state and then assigns what tests you are supposed to execute. So when JUnit runs, it will actually pick up the suite instead of your given test case. So now when I run this test, the output of this test is only one test method that is run, which is the test concat. Okay, I want to be able to pause significantly here for you to be able to understand how you can build this together. But anyway, it's not terribly complicated, except that when you have to build multiple sets of different types of tests, it can become a little heavy. The way I like to look at it is, the suite allows you to package your tests into more specific use cases or scenarios. So now you've written, like I said, if you've written something to the range of 70 to 100 test cases, each of them fulfills a different type of a function. For example, one of them determines how many, on an average, how many timesheets, for example, you did not fill. Just for an example. So what you can do is essentially with this kind of the suite call, you can then plug of those 100 tests, maybe 20 which pass through a certain functionality, and say, okay, for this particular case, I'm going to use these tests. And as you can imagine, all this becomes, obviously a lot more flexible as you go and play with different scenarios. You can merge. You can not only just simply add tests to suites, you can also add other suites to the suites. So the whole exercise of making bigger and bigger packages obviously gets more and more complicated. However, the general suggestion is, one second. Okay. However, the general suggestion is that you are doing unit level testing, and you should tend to stay away from complicating your life. These kind of test harness suites, etc., are generally areas of integration level testing, QA level testing, acceptance level testing, and should not really be your concern unless a specific scenario demands it. There are certain scenarios which will demand packaging and building components together and testing them in one go. But more often than not, you should be sticking to the class that you are looking at, and then the output of the specific thing that the class does. And that should be a very, very straightforward set of test cases that does that. However, even in a simple class scenario, you can imagine that the certain combinations might make sense, and you may want to group them. So we understood the fact that we can do initial context for every test that we run. So for a particular test that we run, we set up the context, we run that test, and then we go to the next one. Now what happens when we are creating these packages of different tests, when we are combining all of them together, and then we want to run them? What happens to the setup method? Now what a problem with the setup is that it's going to execute before every test, right? However, we want to be able to initialize a context for a given set of tests. the way that is done is you extend the test setup and then wrap it around the test suite. Let's see how it is done. Okay, so I have given a very simple example here, so which is so as you can see in this particular case, you have the same test suite. However, it has been augmented by a new class, the test setup that we are using there, which defines its own setup method, right? So what we are actually doing is wrapping up a test setup, wrapping up the suite in the test setup method, and then that's what you're actually essentially going to use. So this allows you to define initial set of conditions for the range of tests that you're running. Like I was saying earlier, suite as well as context setup at the level of suite is not recommended, because you want your test cases to be as isolated as possible. You don't want to build this tree and web of interconnected tests which you have to run all together at one time. That almost in a certain sense defeats the purpose of unit testing. So therefore, generally not a good idea, but there are obviously situations that they will need that will need them. Okay, and my suggestion always is that if you want to define certain types of scenarios where a particular flow of logic goes through a use case which has to step through a certain 3 or 4 different operations before it does final operation, etc. It's a combination of different things, and the state actually is going to change. And if you really specifically want to test that state change, you should do that scenario or use case based on that. In general, tests should run independent of each other. Now we have discussed this scaffolding. We have taken a couple of examples on how those test cases are written. We have understood what some of the assert statements do. We have understood the whole piece by piece, how these tests get packaged together. Obviously, the most critical part of this whole thing is actually the asserts. So the actual test is done by the assert statements. Okay, and obviously intentionally and in keeping with the JUnit philosophy, they are actually even simpler than most of the other constructs that we use. We know that assert can include an optional error message as the first argument of the assert method. And assert will test a reference value against the actual value returned by the unit under test. So there are different types of assert methods and different variations of each of these, and obviously you can understand the signatures are different to support things like being able to pass a message and different types of other types of constructs as well. But in general, the top level assertions boil down to assert true, assert null, assert same, and assert equal. As you would expect, they are supplemented by the negation of each of these test cases, test conditions, which is assert. Therefore, again, assert, as you can assert true, you always go and assert false, assert not null, and assert not same. I assume that we don't have to explain what assert true means, right? I mean, it's obvious, but maybe it's worthwhile spending a moment here. An assertion essentially says that this should be the case, right? It explicitly defines that this particular object should be true, or that this particular object should not be null, or the fact that these two objects are just the same thing, or the fact that these two are equal. So there is assertion essentially is a clear indicator of what you want the program, what you specify the program should do in once a particular operation has happened. So I have not listed all the different types of assert equals, but there are many based on their overloading. There are different types of signatures, each for primitive and object types, string, boolean, char, int, and object types as well. So there are several different assert equals, but at the broadest level, this is all you have to deal with to be able to write your test, and you generally don't need anything more than this. However, in some cases, and I know that somebody would want to ask that question. Okay, before we go there, I have already said on this before. I have said that multiple asserts are typically used in a method, right? It's not a single assert. Your operation has happened, but the outcome of that operation, for example, either it could be a collection, it could be different, it could be just a simple object. But there are different types of conditions that the objects must meet for you to be sure that it is valid and it is the right thing that the program has done, and therefore there are many assert statements in any given test. Okay, then coming back to the previous question, it is essentially yes. You typically don't need anything more than the standard asserts that are available to you. However, excuse me. However, you may want to be able to customize specialized assertions, and it is possible to do that as well by adding assert whatever method with the method name assert whatever method to the class that derived from test case. Once you derive a particular class from test case, you can then extend that class to essentially inherit all the customized assert methods that you have written. I'm not particularly giving an example of that, or rather code example, but you can imagine, for example, like I said earlier, is that assert employee. For example, you want to use this so many times that you don't want to go testing that particular condition, but you have created a keyword for your own test case saying assert is employee. So that could be a method that you create for as a customized assertion that you want to include in your test. So those kind of situations are possible, and all you have to do is extend from the test case, write your assert methods, and then derive all your test cases from your extended class. Okay. Finally, the whole purpose of being able to test is obviously being able to understand that it works and that the output is actually correct and verifiable, and therefore there is an equivalent result class in JUnit. Okay, a result class is nothing but the container for the results of the entire test run during a JUnit execution. So it contains all kinds of things. I mean, essentially it captures all the results, it stores them, and then you can do a whole lot of things with what with the result that you obtain. First is obviously you can get the error counts, failure counts if there are any, run count, whether or not it was successful. This is the wrong method name actually. The method name is was successful. Right? This is not the correct name. So you can query the result for all kinds of different outcomes and scenarios. You can also plug in listeners while JUnit is executing to monitor the test execution yourself. So in specifically long running kind of I would assume somebody would gasp at the statement long running somewhere in the audience. It's good I use that, but the important thing to remember is that your test should never be long running. You should never have long running unit tests. You should never have tests which are so complicated that take a fairly long time or a whole bunch of tests. Tests should always be very specific, and they should execute very quickly. It's very important for the test to get in and out of the condition that they are in fast. However, there might be a whole set of tests which takes a significant amount of time to execute, and there is like I said, typically we're talking about 70 to 100 tests, and then all of them have to run, and therefore you may be interested in monitoring or looking for a specific condition for the code that you're debugging. So you could essentially develop custom listeners which then plug into this different JUnit methods and pull out information at point of when that test is executed and what happens, and these are different listeners that are there: the start of test, end of test, error and failure. Now this is what is used. This is what is used typically as hooks from all the other plugins that you have into JUnit reporting, things like cruise control integration. There are a lot of other tools, a lot of other lifecycle tools which essentially plug into this functionality of JUnit to be able to produce a better quality of results. HTML style results, XML style results, email results, all kinds. You can do. I mean, obviously, once you have listeners, there is almost infinite number of things that you can do with it. So that's how the external plugins to JUnit work. Okay, I am going to take a breather here because this brings us towards the end of this topic. But I would like to preferably take questions on JUnit here before we move on to a topic that is slightly disconnected from the earlier thing that we were discussing. Ravish, Sudhita, anybody there? Do you want anyone to? Do you want anyone to take a questions or discuss anything right now, or should we continue?
I think we can continue.
Okay. Okay. Now, just in just a moment at past, we discussed the fact that tests should not be long running. Tests should not depend on a whole lot of things. JUnit tests should be fairly isolated and atomic in their nature, and they should be self-contained. Which brings us to the issue in a typical production environment. And the question that I would have expected people to raise is that what happens when you have, for example, a program that actually uses JDBC to connect to a database and retrieve value, or for example, a program that uses a web service to connect to something, or a particular method that is extremely long and does not execute in a given time frame for you to be able to limit your time for the test. The TDD session was conducted last week, and I assume that you all have a background in terms of how TDD and what is the implications of TDD. But one of the important requirements of TDD is that you write the test before you actually write the implementation, not after. You don't write the test. Although I started off the session by saying that the tests are verification of your code, TDD turns this concept around by saying that the code is actually a verification of your requirement. That's pretty brilliant. I mean, if you look at it in a certain sense, it's the code that has to satisfy the conditions that you've laid down. So you've laid down certain types of requirements, and your code is catching up to meet with them, and therefore you write those constraints upfront. So resolve those constraints, solve them in the simplest possible manner, and keep working through your code to add additional test cases, additional conditions, additional requirements which your code must satisfy, and then work on it. In a very strict TDD environment, the suggestion is that you should never move ahead unless your test failure has been resolved. You should never ignore failures in tests. And therefore now, if you look to combine these two principles together, essentially one is that test is a requirement which defines the constraints against which your code must deliver. It's a pretty powerful concept that it goes in the other direction. You're writing code to satisfy the conditions that you established, and obviously once you've written that code, that test harvest continues to validate that those requirements are met, and therefore your regression is taken care of, and you have quality and your robustness and all the reliability, etc. Obviously it gets built in. Therefore that is the great magic of it. You start by actually specifying requirements, you write code, and then the same set of tests continue to verify that your code stays true to its original set of requirements. Now the other place it says is, you're never going to move ahead unless your tests have been resolved. So you don't ignore tests. You don't write 25 tests and then work on all of those different tests at the same time, and all of them are feeling all over the place, and you're happily coding away. That is not the thrust of agile. That is not the thrust of doing TDD. The thrust of TDD is you write. It's okay to write 5 or actually 1. Resolve that particular test case and then move on. You could definitely create test stubs, for example, which essentially are something that are pending tests, and therefore you would have to work on them at a later point of time. So you mark them, like I said earlier, that you don't prefix them the test method and they become pending. So those pending are placeholders in your mind, but that still does not say that those pendings can become those 70 tests that we are talking about. You don't define all the 70 tests for a particular given class upfront and then say, okay, now I'm going to start writing this class. You spell out the test, then work on it, and then add tests, and then resolve them, and that's how it all should work, right? And during this scenario, if you have reached the 18th test and you have resolved it, but during that resolution the 12th test case failed, then the first thing you have to do is go back to the 12th test case, fix that, and then come back to the 19th. That is how TDD scenario should work. However, that is again not the focus of discussion today. We are trying to focus on obviously JUnit and how we should leverage them to make all this possible. So first of all, we need to eliminate all external dependencies. In multiple team environments, etc. You have different teams working on different types of different terms. Some guys are working on the message broker. Some people are working on the UI. The other people are working on some utilities. There are parts which are working on struts. There are basically 4 or 5 streams that are actually converging to become a particular product or a unit or software that is actually going to be delivered. In other scenarios, a developer may not have access to specific stack components. Right? I mean, not all machines are capable of, for example, being able to install Hadoop. Hadoop is, is one of those. Is basically a big data, a file system, essentially by Yahoo. If you go look at it, it is typically used in web environments these days, and it is extremely powerful in terms of, what is called as a big data capability. Again, Hadoop is not the focus of the discussion, but idea is that there are definitely certain stack components. Given the limited workstation resources that you have, there is always a possibility that you can actually never have all the stack components. There might be some extremely specialized stack components which are, for example, extremely pricey and licensed only to the enterprise, and the usage of those is subject to each end user's developer license counts and whatever conditions you can imagine, right? I mean, so there are many limitations. So the developer may not have access to those components. A developer's machine may not have the resources, and the most important thing of all, in an agile environment and in a more fast-moving environment, developers are typically working around the clock, working after hours. They have flexible times that they're working with. They're working. They're generally in startups and stuff like that. For example, there are some work from home kind of scenarios. So there are many different scenarios in which all of the whole environment that you're supposed to develop against is not available to you. You are only lucky to have such a scenario happen. So what do you do in this scenario? So we use what is called as test governance. Okay. One of the important concepts in object design is to program to an interface, right? And and hopefully it's a technique that we are using in multiple places. But essentially, when we talk about using an array list, we use the list reference to work with it. The simplest example, you are always interested in the whole point of it, encapsulation, abstraction, and all the object-oriented design principles essentially is to be able to protect you from the idiosyncrasies of the implementation and all the stuff that goes in. And this hiding away of the implementation, again, in one sense, connects very powerfully to the concept of TDD and unit testing, where your program may solve a particular requirement or a particular test case by implementing any code that it wants, but that code is always hidden away from the actual usage of the object, from the actual interface that the object exposes, and from its real condition. So later, when your test changes or test adds new constraints, your interfaces do not necessarily change. I mean, you may have new interfaces and they still continue to be interfaces, but you don't know what has happened behind the scenes. It is very safe for you to go ahead and refactor that part of the code and write it in a different way without the user or the client that is interested in the object ever getting to know about it, and therefore now your tests are also decoupled from this whole business of your implementation, right? And that is precisely the principle we carry forward with mock objects. With mock objects, essentially what we are doing is we are saying that this is the interface we want to satisfy, and you can obviously identify with this immediately because you would have come across scenarios where another team is working on providing you some kind of a library for certification, so security certification or something like that, and there is a specialized team that is doing that, and that code is not generally available to everybody, and only some few trusted people are working on it, 2 or 3 people who know the security environment, and therefore that cannot be exposed to the general team and as a corporate policy. So that's an extreme example, but obviously in most regular day-to-day scenarios also we are waiting on certain libraries or certain dependencies to get ready, and during that time you have to still work on your code and still develop your code. So essentially what we do is we define those interfaces to work with, and then what we call it is the mock dev behavior for the unit under test. Okay. So it does not actually run through the execution of that specific class or object that you are looking at. It only mimics that behavior. So now, how does that, in conjunction with JUnit? I mean, although this is, this is not core JUnit in a very typical sense, but discussion of JUnit obviously is incomplete because the discussion of testing is incomplete without being able to talk about what are mocks and how they're used. So the easy mock framework is an extension to the test environment, to the JUnit test environment, not necessarily a part of the JUnit test environment. Okay, and so there is a framework called easy mock, and there are other frameworks as well. Okay, and there is another framework called Mockito, and I personally prefer that. It's a good framework. There's also something you can go look up on the web and read about it. But this is the one that we are using internally, and it has fairly powerful capabilities. And as of version 3 onwards, it has become almost as good as the Mockito. Although there are certain design principles which are different between the two of them. Okay, so with easy mock, we specify which method calls we want to mock. We also specify for those mock methods what the return values of those mock methods should be. So the way it works is that there is something called as a recorder. First, what you do is record the action or the mock or the method to be mocked, and implicitly specifies return values, so that it appears to the client or the code or the object, the class, the unit under test, that you are getting values as though they were coming from the original class and the original method in operation. For testing that specific method, we replay the recorded mock. So here's an example that for the mocking framework. Okay, so there is something called as, so I do not know what this discount maker does. Okay, all we know is that there is something called as a discount maker, and we don't have access to it, or we either don't have access to it, or essentially it is a class that again connects to a whole lot of different services or has some other issues, and we don't really want to actually plug it into our unit test case. So what I do first is just define an interface on top of it. So now I have defined an interface called discount maker, and it has a single method which is called discount. How to basically get the discount for a given condition, or basically in the source and the member. Then we have the customer class. The customer class actually uses the discount maker. So the customer class, or a customer has a name, whether or not the customer is a member of the participating store, and how many stores is the customer registered with. That's the kind of scenario that we are trying to build here. And finally, when you want to compute, given that condition that he is a member and he has more than 2 stores, he may have different discounts, more than 5 stores, he has different discounts, also all of those conditions are going to be maybe verified against the database, whatever has to be done, we don't know what that is. But the discount gets computed as you can see in the discount method, and you have discount maker dot discount, right? Finally, to be able to mock this particular scenario, what we are doing here, as you can see, is these are all what is it called as basically the scaffolding for easy mock, and there are a whole lot of different things you can do with easy mock as well. I mean, checking for arguments, checking for handlers. There are many different ways you can use. But simple use cases where you do a create mock of the class that we are anonymous, or the class that whose actions we are unaware of, or that is rather better is inaccessible to us. We create the customer class. We again set the mock itself as the as the intended class that the customer is going to use, and you can see in customer membership, in the test customer membership, we say easy mock dot expect for the condition where this discount 5, false is passed, you should return a value of 10x. So that and return is very important over there. That for a particular call to the method of this nature with this argument, the return value should be 10x. We do a replay, we do a calculate. This is slightly imprecise, but let's ignore this for a moment. We do a discount, and then what we say, as usual, is essentially that the discount matches. Okay, terminated by the verification of the interface. So this essentially allows you to build against interfaces, to essentially reference unknown situations, validate your unit in any case, confirm that works as expected regardless of the external dependency that it has. Obviously, there are a lot of assumptions on the fact that you know that this is the kind of value that you return, that this is what you will get out of it. So in a sense, that's really the reason why the interface is locked out. That the return values are going to be this, and the essentially signature is going to be like this. So that does not change, right? That is the important part of how it works. So that constrains the change in the external interface. Obviously, there are situations where the interface there also might change, but then again, it's very easy to then mock that and use the new interface. So you don't get affected by any of the parallel or concurrent development that is happening on the other side of your team, right? That is the whole reason why we use what is called as test server. Okay, so as a as a JUnit review and as a JUnit set of initial tools that you want to start with, this covers what we want to talk about. Okay. In addition to this, obviously there are more complicated scenarios and what you should check for and what kind of conditions you should test for and not test for. There are questions that I was expecting to, I was going to expect to ask, hoping to ask you guys and participate in it and basically verify that you understand what kind of testing we are going to be using JUnit for and how we should typically cover good tests. So that is the part that I wanted to cover in the final run. But before we go there, I would like to give you a sample of test cases in our environment. Okay, as you can see here, one moment, let's go through it step by step. So as you can see, unfortunately not a lot of tests, but there are other classes and cases where there are a significant number of tests, etc. These do cover, in many cases, once again, TDD is not. I mean, when you write TDD, you're actually writing against the requirement. So what happens is, if you have not written a test, you have not developed using tests. What happens is, by the time you finish writing tests, you know that it covers most of the scenario that you're looking at, and you are actually at that point of time at a loss to figure out what I should be really testing for. So what you generally tend to do as developers is essentially cover the most critical conditions and the most standard scenarios, and then wrap it up and call that a test and move on. That is generally not the recommended scenario. However, if you were thinking of code through tests, this would be a much bigger set of tests that you would be up against, because you would actually do it step by step at one any given point of time. Okay, so I mean, you won't. These are obviously real life test cases. So you see, very many different types of. The initial context is a complex setup. Okay, and here is the use of the easy mock that we were talking about, and how those easy mock objects are created. Okay, so we have implemented something like a generic way of being able to do that for different types of objects, and then it gets used in the actual test cases, etc. Most of them are standard scenarios. I don't see a whole lot of exceptions. I mean, typically you don't really need to use those specific exceptions, except this particular keyword called fail, where you are actually terminating the test yourself, saying that this test needs to fail. In other cases, for example, you may use something called as as you can see, what the test is expecting over here is that there should be an exception. Okay, having gone through the step line 144, which is instance.export do, and not having got an exception means there is a problem and therefore the test should fail. There are a couple of other ways to do this. One is the test should itself throw an exception. That is one way of resolving this problem, and JUnit will basically mark that as a failure anyway. So this particular user may or may not be, depends on how you want to use it. And the other scenario is where, for example, you can instead of this particular failure that happens, you essentially use the exception condition as a path, and therefore you say assert true that it has passed through that exception. So there are, I mean, it's kind of without actual use cases and examples difficult to explain, but in this particular scenario, having not got an exception means the test should fail, and that's the keyword that is getting marked over there. And if it does actually get an exception, you can see that there is an assertion there that this is what the exception I should be getting. Okay, all of these are bound into test harnesses via and build file, and there are a whole lot of scaffolding that we have around how this whole thing runs in an automated build environment. But we have hundreds of tests that run at any given build cycle to verify against all this, and therefore every build cycle we are making sure that no new regression issues, no new failures, nothing has been introduced, and at least from our personal use case scenarios, what we do is instead of enforcing the TDD or failure at the point where the developer is actually, we enforce it at the level of the build cycle, where when a build particular fails, or if there is a problem where your test don't pass through, then you don't check in the code, you make sure your test pass, write the specific, clean up your test, and then make it work. And as soon as there is any problem or a critical failure in the actual build, if things should stop, you should fix it and then move forward. Okay, so that pretty much brings us to a close on this session, and I would like to take that move this to other people, participants, questions, and take any specific things you want to discuss. But like I said, for me, the next topic of discussion is essentially what are the types of things that you write through tests. How do you make them, how do you make them more, valuable when you're writing those tests? And that's one of the more important things to be able to learn how your tests are, how your tests actually can add value to what you're doing. And therefore, it is important to cover a whole broad range of scenarios. Unfortunately, that's the skill we firmly believe belongs in the QA department. And to resolve the thing, the general recommendation is that the QA and the development team should work together. In fact, one of the people that I met in the Agile Con told me that essentially QA team should be made of either of developers. The QA team cannot have a skill set that is different as compared to the developers, and therefore they both necessarily have to talk the same language, and they be able to communicate to each other that this is the constraint and this is the requirements of the product that we are going to be able to use, and the QA needs to be able to feed to the development that so the development are nothing but the programmers, and the QA again are a different set of programmers which are now contributing to how this test should be created. So if we have time for that, we'll go spend some time, and I would like to ask questions in how you use, and then tell you what you should do. Otherwise, we'll go for questions. Ravi?
If anyone would like to ask questions, please raise your hand. You can also use the question and answer box if you want. So we don't have any questions, Rajiv, for now. If you need any information or have any questions going forward, do send us an email and we will try to answer those questions offline. So anything else as a closing note you would like to add, Rajiv?
Yeah. So, like I said, I would definitely want to take an extended live session if people are interested in actual code walkthroughs and taking a specific type of samples and running them through different scenarios, which would be more of a half day, a longer session. I would definitely be interested to do that. The other thing is to make sure that the philosophical shift happens. It is essentially, I hope I have been able to communicate that sense. And we need to be able to understand that the development and the testing activities are not dissociated from each other. They are essentially the same thing. And as I have said, and I couldn't have said it any better in the initial slide, is that at any given point of time, you are always verifying your code, because otherwise, obviously, you won't be delivering anything. The only thing is that your test methodology differs. The way you're verifying it differs. The JUnit, automated testing, TDD, etc., bring you to a much higher level of how you build your code, how you make sure it is verified, and how you make sure that once it is verified, it stays there. And that's the key to unit testing and automation. Okay, that's about it.
Thanks, Rajiv. Thanks for the wonderful session. So we will send you an email with a polling for how many people would like to attend that extended session, as well as for your feedback. And thanks for your time. Thanks, everyone. So I would like to ask again, does anyone have any questions right now? Please raise your hand. I will wait for 30 seconds more. So I think we will close the session now. Thanks, everyone. Have a nice day. Bye.